Alright, so this video is to help you do lesson 15. Before I show you an example of what you need to do, let's talk about a couple things. So the first thing I want to talk about is NaCl. Right, so sodium combined to chlorine. So when we created the previous card, and make sure that before you move into this video that you have a card that looks somewhat like this. We talked about that this family loses an electron, this family loses two, some of them gain electrons, but how is that they gain and lose electrons? They do that by actually bonding to each other. So sodium, which belongs to this family, right, has one valence electron. Chlorine, which belongs to this family, has 7 valence electrons. So there we go, 1, 2, 3, 4, 5, 6, 7. So 7 electrons, 1 electron. Based on this, we know that chlorine gains an electron and sodium loses an electron. Very convenient. So what's going to happen here is that this electron is going to be pulled away from sodium and into chlorine's region. So they're going to end up looking like this. Na plus, right? It has the charge of plus. And Cl1 minus because it gained an electron. The plus and a negative attract each other, so it's going to combine to form NaCl. The other thing I wanted to point out to you, it is a 1:1 ratio. In other words, per 1 sodium there is 1 chlorine. Let me show you a case where that is different. Okay, and let's kind of work backwards. Something that you use quite a bit in the lab is calcium chloride. It was the substance that in the presence of water got really hot. In here, it's saying that per 1 calcium there are 2 chlorines. In other words, per 1 calcium there are 2 chlorine ions. If we find calcium in the periodic table, you're going to notice that it has a valence electron of 2. So I put here 1, 2. And if I look at chlorine, we talked about that before, it has 7. So 1, 2, 3, 4, 5, 6, 7. Okay. 1, 2, 3, 4, 5, 6, 7. And the location I'm putting the single ones, I'm just doing for convenience sake. So here's what's going to happen. We know that calcium is going to lose those 2 electrons. It says right here, loses. And it says loses 2 electrons. So one is going to go to this chlorine. The second one is going to go to this chlorine. So it is going to be calcium, which lost 2, and chlorine, each gain 1. The ratio is 1 to 2, right? There's 1 calcium per 2 chlorines. So when we write the formula, it is going to be calcium chloride. Calcium, 1 calcium, 2 chlorines. That's how you show how many are present. Alright, so now let's do an example on page 17. Done this one already. Let me find something I haven't done. Alright, here. So again, he explains a couple things for you here. Make sure that you read this. This is just a reminder from yesterday. Formula is what we talked about before. It's the lowest whole number. Okay, this is an example of a formula. Alright, so the first thing, I'm binding magnesium to chlorine. So magnesium, look at your periodic table as well as your card. It's going to have 2 valence electrons. 1, 2. Your chlorine is going to be similar to what we did before. It's going to have 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. The same example I gave before, where it's going to go to 1 and this is going to go to the second one. Like a very common question that people ask is, how do I know that there are 2 chlorines? Well, you have to really think about that each chlorine gains 1 electron, and you have magnesium here that is giving 2 electrons. So there must be 2 chlorines in order for each one to get 1 electron. Right? The charge would be magnesium 2 plus, each chlorine receiving a negative charge. There are 2 chlorines per 1 magnesium, so the formula is magnesium chloride. So that would be the formula. There is a shortcut to making sure that your formula is correct. So let me show you the shortcut. I'll put it down here. How to double check. Okay, so how to double check? You have magnesium and you have chlorine. Okay. You know that magnesium is going to form a 2 plus charge. Magnesium 2 plus charge. Chlorine 1 negative charge. There's a technique that people use which they call a crisscross. The 2 over here is going to go to the bottom. The 1 is going to go here. And again, this is not a scientific rationale. It's just a shortcut that someone discovered in order to double check that you did your formula correct. So if you crisscross them, you're going to end up with magnesium 1 and chlorine 2. So again, this is a way to shortcut, so I know that this is the formula, but make sure that you are able to write exactly the mechanism in which the formula is derived. Alright, so I hope this has helped you. Go ahead and finish the rest of lesson 15 and let me know if you have any questions.